Hey, hello everyone, my name is Maghfiroh. Here I want to present about our results with this performance evaluation of Fuzzy-PID in speed control of 3-phase induction motor. This research is done with our colleagues, which are Mr. Joko, Mr. Feri, Mr. Augustinus Sujono, and Mr. Lulus Lambang. Here is the outlines of our presentation, starting from background, system design, result and discussion from two tests, and then conclusion. Background. Induction motor is one of AC motor type which is mainly applied for adjustable speed application and consume approximately 60% of the total industrial electricity consumption. An induction motor can be found in the industrial and traction system of electric vehicle. Induction motor is chosen due to its simple structure, reliability, high efficiency, and low cost, while PID is one of the control type that reported use by 90% of industrial section because of its simplicity, applicability, and reliability. However, PID has two major shortcomings, namely the determination of parameter of PID and its performance decrease as system condition changes. Therefore, the online tune of PID parameter is needed to make the control system adaptable with condition changes of the plant. Fuzzy Logic Controller or FLC is one of the artificial intelligence that can be used to online tune the PID parameter as proven in reference 7 in our papers. And in this research, the performance of Fuzzy-PID in speed control of 3-phase induction motor will be evaluated. System design. We done our research in MATLAB simulation environment. As we can see here, this is a simulating block for our research with using a DTC method of induction motor control, and this is the parameter of our motor, which is 149.2 kVA. And then this is speed control and DTC. Here is the block inside the DTC induction motor drive. There are two controllers. The first one is speed controller, which we using Fuzzy-PID, and the other one is DTC. DTC means direct torque control that used to control the torque and flux as shown in this block diagram. So DTC is the one way to control induction motor, which control the torque and also the flux here. And we do the two tests, which is no load test and the loaded test. The first one is no load test. No load test is representing a linear road in electric vehicle. PID has maximum overshoot of 1.6%. We cannot see here because it's too small. But from the quantitative data, it calculates that the maximum overshoot of PID is 1.6%, while Fuzzy-PID has lower than 1% of overshoot. And the second one, Fuzzy-PID has better torque performance. Here is the torque performance. The red one is PID, while the blue one is Fuzzy-PID. Fuzzy-PID has better torque performance with faster in following the reference. And the last one is from energy. Fuzzy-PID consumes 4 0.5% higher energy than PID. However, it has better performance. This is the integral of the energy. It means that this is the final energy used in this range of time. Then the second one is loaded test. In this test, we varied the torque load, as we can see here. While in the first one is, here is the torque is higher because the speed is increased, and when the speed is constant, it nearly zero, and when the speed is decreased or break, the torque is go down, and then it's constant again, and then break is go down again. While in loaded test, we give the load variation. So this is increase and this is increase again. So this is some decrease in speed because of the load added here, and then here at the constant speed we give the load is nearly 800, and then this is also, and here when the speed decrease, the torque is also decreased, but it seen that the torque output can still follow the reference. And the loaded test represent the road with gradient. Both algorithm affected by these load changes. Here we can see, but Fuzzy-PID is more stable. On the other hand, PID can reach the set point well, whereas Fuzzy-PID cannot, but still inside the tolerance, which is plus minus 1% that we use in our test. Fuzzy-PID consume lower energy by 1.03% because the energy consumption, the last energy consumption here is consumed, is calculated and means by this is consumption and this is breaking. So the total is here increase, and when break some decrease here, and the last one the total energy consumption here. At the end of the simulation, Fuzzy-PID consume the lower energy than PID. And the last one is the conclusion. The simulation results show that in both no-load and loaded tests, Fuzzy-PID give better result in speed tracking. This method also gives better torque response compared with classical PID. In terms of control energy, Fuzzy-PID consumes more energy by 4.5%. However, it has better performance, and whereas for the loaded test, it also has better performance with less energy by 1.03% compared with PID. And we add the conclusion that the more speed variation and load variation, Fuzzy-PID has more advantage than PID. And thank you. This is the end of our presentation.